Hi students, and welcome to the first week of our SHSAT training program. This week's math topic is going to be absolute value and strategies we can use for solving absolute value of equations and graphing absolute value functions. The first step is defining what an absolute value is. The absolute value of a number is just its positive distance from 0 when graphed on the number line. For example, 2 is going to have an absolute value of 2 because it's a distance of 2 away from 0 on the number line. However, if we look at a negative number like -3, since the distance of any line can never be negative, it's going to have an absolute value of +3, since that's how far you need to travel to get from -3 to 0 on the number line. Using this information, we can come up with a general formula for the absolute value of a number. The absolute value of a number x is equal to either x when x is greater than or equal to 0, because then the positive distance is the same as the number, because the number itself is positive, or it's equal to -x if x is less than 0, because a number like -3 is going to be 3 away from the number from 0 on the number line, because negative distances don't make sense, they don't exist. So yeah, basically the absolute value of a number like 2, as I said, equals 2. The absolute value of -3, or any negative number, is just the inverse of that number. So in this case, it would be 3. And the absolute value of 0 is 0, because the distance from 0 on the number line is just 0. So using this, we can solve certain equations. For example, this equation, the absolute value of x equals 4. We need to think what numbers are 4 away from 0 on the number line. So there are two numbers, because you can go 4 in the positive direction or 4 in the negative direction to get to a number that's 4 away. So x can actually be two things. X could equal 4, or x could equal -4. We can also use the formula from before. If we think about what number multiplied by -1 gets you 4, the number is -4. And since -4 is negative, the absolute value of -4 would be -1 times -4. So -4 works, and 4 times 1 equals 4 as well. So 4 works as well as a number whose absolute value is 4. Now we're going to look at a slightly more complicated equation. The absolute value of n plus 9 equals 13. So there are two possibilities for what n plus 9 could be. Either n plus 9 could be 13, or n plus 9 could be -13, because both 13 and -13 have an absolute value of +13. So let's look at the first case. n plus 9 equals 13. Well then, to solve that, we would have to isolate n. So we would subtract 9 from both sides of the equation, and we get n equals 4. So this is a possible solution. However, since this is an absolute value equation, we have to also look at when n plus 9 equals -13. And there it's going to be very similar. So we look n plus 9 equals -13. This is the second case. So we subtract 9 from both sides. And -13 minus 9 is -22. So n equals -22. So both of these numbers, n, work as a number that when you add it to 9, the absolute value of your result is 13. So n equals 9, or n equals -22 are our two solutions. So now we're going to look at a slightly more complicated equation. Absolute value of 3x plus 4 equals 19. So we know that either case 1, 3x plus 4 equals +19. And the other case is 3x plus 4 equals -19. So now we just need to solve both of these equations to see if those numbers x make sense. So if we look at this, 3x plus 4, and then you subtract 4 from that to just isolate x, equals 19 minus 4, which is just 15. So, 3x equals 15. So you can divide both of those by 3, and you get x equals 5. So now you can go ahead and plug 5 back in to your absolute value of equation to make sure that 5 is not an extraneous solution that you generated. So we know that 5 times 3 is 15. If you add 4, you get 19, and the absolute value of 19 is 19. So 5 is a solution to this equation. We can do a similar thing here. So 3x plus 4 equals 19. So 3x, so you can subtract 4 from both sides of the equation. So you know 3x equals negative 23. You divide by 3 on both sides to get x by itself. You know x equals negative 23 over 3. So again, you can plug that back in. So negative 23 times 3 divided by 3 is negative 23. And when you add 4 to that, you get negative 19. And we know that the absolute value of negative 19 equals 19. So negative 23 thirds works as a solution for x. Another important feature of absolute value of x is the graph. So if you can imagine it, since you're negating every number below 0, it's essentially just going to look like a normal y equals x graph, but with the left half or the half to the left of the y-axis reflected over the x-axis. So it's going to have a V shape, as you can see in the blue graph here. So the blue graph is just y equals absolute value of x. So one thing you can do is you can horizontally translate it either to the left or to the right. And this part is a little bit counterintuitive, but it makes sense if you think about it. So if you add 1 inside the absolute value, the graph gets shifted to the left 1 unit. And if you subtract 1 or you add negative 1, it gets shifted to the right. But this actually makes sense because the 0 of y equals absolute value of x plus 1, or the number it's centered around, should be the number that makes x plus 1 equal to 0, which is negative 1. And similarly, y equals absolute value of x minus 1 should be centered around positive 1. So subtracting 1 inside the absolute value shifts it to the right by 1 unit, and adding 1 shifts it to the left. And 1 is not a special number. Subtracting it any distance will shift it to the right by that distance, and adding any amount, not distance, will shift it to the left by that amount. And the other thing that can be done is you can do vertical translations of y equals absolute value of x by adding or subtracting numbers outside of the absolute value. And this is a bit more intuitive. So adding 1 outside of the absolute value, as you can see here, shifts the graph up 1 because this is a distance of 1. And subtracting 1 would shift it down 1, and you can combine these. So in the case of y equals absolute value of x plus 1 would be the just normal y equals absolute value of x shifted up 1 unit and then to the left 1 unit, because x plus 1 shifts it to the left, x plus 1 shifts it right. So this distance is going to be 1, and this distance is going to be 1 as well. And that's going to be the center, and it will just have the same shape. So yeah, that's about it for absolute values. We hope this is helpful. Feel free to drop any questions in the comments if something remains unclear, and we'll see you next week.